Sir, you didn't reshare the screen.
Wait. I'm resharing the screen. Can you see my screen, ma? Can you see my screen?
Yeah.
Okay. So this fellow, what is happening? He is initially at 0. That means next to you. His distance is increasing with time. Okay. But he
Mhm.
is covering equal distance in equal time, right? In 2 hours is covering 4 kilometers. Next 2 hours again another four. Next 2 hours again another four. Next 2 hours again another four. Like that, right? Similarly, this fellow is also covering equal distances in equal time, right? In this 2 hours, he has covered this 4 kilometers. In this 2 hours, he has covered this four. In this 2 hours, he covered this four. In this 2 hours, he covered this four, right? Right. So both are covering equal distances in equal time. What is the difference? One fellow is coming towards you, another fellow is going away from you. Okay, ma?
Yes.
Okay. So now I will draw some other graph like this. Okay. This graph. Now look at this graph and this graph. Here, what is happening? This fellow is covering 4 kilometers in 2 hours, first 2 hours. Next 2 hours, he is covering actually 16 minus 4, 12 kilometers. Understood? Okay. His speed has increased. He is able to cover more distance in the same 2 units of time. Agreed? Initially,
Yes.
0 to 2, he has covered 4 kilometers. Next 2 to 4, how much he has covered? 4 to 16. Understood?
Hmm.
Okay. So basically, what does that mean? He has covered more distance in
More time.
in the same time. Understood? Between 2 to 4, he has covered from
Oh,
4
like
to
that.
16.
Yes, yes,
Okay.
understood.
So he has covered more distance. What does that mean? His speed is increasing. Otherwise, he cannot cover. No, his velocity is increasing. His velocity is increasing. That's why he's able to cover more distance in the same time. Agreed. If
Yeah.
his velocity was not increasing, he would have covered again another 4 kilometers only. He would have been here. He would have reached 8 kilometers only. But now he has reached 16 kilometers in 4 hours. What does that mean? His speed has increased. Okay,
Yeah.
understood. So basically, again, now remember this distance time graph. Okay, this is distance. This is time. Distance time is a curve like this. Okay, okay. Is a curve like this. You can see, right? This is kind of U-shaped curve, right? The right
Yeah.
half of the U. If this is a curve like this, what does that mean? This is accelerating graph. Okay, speed is increasing. Okay, ma?
Yeah.
If the speed is increasing, what does that mean? There is some acceleration.
Yes.
Okay. Now, um, now, I'll write some other graph. Okay. Okay. Now look at this graph. Okay. Look at this graph. This green one. Okay. Initially, in 4 hours, he has covered 2 units of distance. Okay. Next 4 hours, he has not covered 2 units only. Okay. In the first 4 hours, how much he has covered?
2 units.
2 units. Next 4 hours, how much he has covered? Kind of 1 unit only. Right?
3 minutes.
So total is so in this part only. This is the additional distance, no? Okay. This is the additional distance. Not in, okay. Not two. And in the next 4 hours, 8 to 12, he has covered till this part only. Not even one. Right? In the next 4 hours, he has covered even lesser. Understood? So what does that mean? His distance, he's slowing down. Agreed. Initially, he was able to cover more. Okay. In the next 4 hours, he's covered even less. In the next 4 hours, he will covered even more less. In the next 2 hours, he has covered even more less. Okay. Understood. So
Yeah.
basically, this kind of graph. Okay. This kind of graph. Okay. This kind of graph is retardation. Okay, ma? This kind of graph is acceleration. You will remember, no? This
Mm-hmm.
is kind of opposite to this. Okay. This
Okay.
going up, is kind of acceleration. You are covering more and more distance. Okay. This one is you are covering lesser and less distance. Okay, Amma?
Okay.
Okay. So now this is accelerating, this is retarding. Okay. That is what he has mentioned. So what is that? This is accelerating. Okay.
Hmm.
Agreed. The
Yeah.
other one, this one, something like this is actually retarding. Okay.
Okay.
Okay. So both accelerating and retarding means what? The velocity is not uniform. Okay.
Velocity is not uniform. Yes.
Uniform. In this case, velocity is increasing. In
In
this case,
retardation, it's decreasing.
velocity is decreasing. Okay. Agreed.
Yeah.
Okay. This is in terms of distance and time. Okay. Now, if you do the same thing, okay, in the first case, let's say for the distance time, okay, this is distance, this is time, this is time, okay. There is this kind of graph. What is this graph? In this graph, velocity is constant, right? We are
Yeah.
covering equal distance in equal time. That's what we have discussed. Okay.
Yeah.
1 second, ma'am. Can you see my screen, ma'am?
Yes, sir. I
Okay.
can.
So distance time graph, if it is a straight line, what does that mean? Velocity is constant. Okay. That means velocity is not changing with time. Okay. So corresponding to this graph, if you have to draw a velocity time graph, that is this. Okay.
Hmm.
Because here velocity at 1 is same, velocity at 2 is same, velocity at 3 is same, velocity at 4 is same. Okay. The velocity is not increasing. It is not increasing, not decreasing. So this is a flat straight line. Okay, ma?
Yes.
Agreed. So what does that mean? Distance time, this one, then velocity time, this one. Okay? Both are equal. Agreed? Distance time is this one, velocity time is this one. Okay?
Yes. Yes,
Okay.
sir.
Agreed. Now, distance time, this one means velocity is increasing. Okay? That is this one. Okay? This is velocity, this is time, this is distance, this is time. Okay?
Yeah.
Okay, distance time, this is increasing, this is increasing. Okay, distance time is like this, then velocity time is like this.
But
Okay,
uniform velocity and uniform speed looks
what
uh,
ma?
uniform acceleration and uniform motion look same, right?
Uniform acceleration. No, 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 no. That is different. No, see,
Right?
no, uniform acceleration, we did not discuss it. We are discussing about uniform velocity and non-uniform velocity. Okay,
Hmm.
okay. So we are discussing about uniform velocity. That means velocity is not changing. We are discussing about the case velocity is increasing. Okay.
No, no, I'm asking in general.
Uh,
Like,
in general, most of the cases that you get are uniform accelerations only, where acceleration is generally
like in normal cases,
ah,
I'm
ah,
saying in the distance time graph, uniform motion, and in velocity time graph, uniform acceleration look same, right?
right. So this is uniform motion. Okay, this is constant velocity. This is
Okay.
constant acceleration.
Yeah.
Okay, this is constant acceleration. Okay, this is constant acceleration graph, and this is constant velocity graph. Both will look similar. Okay, both are straight lines. Okay, so basically distance by time is what? Velocity, right?
Yeah.
If distance by time is velocity and velocity by time is what? Acceleration. If this by this is constant, this is generally straight line. Okay. This by this is constant, this is a straight line. Okay. Understood. So
Right.
with you learn about slope of the graphs and all. Generally, when slope of the graph is constant, obviously it should be a straight line. Okay, you learn those details when you learn about coordinate geometry. Okay. For now, you remember that if it's a uniform motion, that means velocity is constant. This is a straight line. Distance time is a straight line. If acceleration is constant, velocity time is a straight line. Okay, but distance time is like this. Okay, when acceleration is greater than zero. Okay,
Okay.
okay. Now we discussed about another graph. Okay, what is the another graph that we discussed? This one, distance time. What is this? Velocity is decreasing. Okay, agreed.
Okay.
This is velocity is decreasing. So this graph will look something like this.
Hmm.
Okay, ma.
Yes.
So initially, uh, velocity was something. It is slowly reducing. Okay, ma.
Okay. V
Now,
0.
see here. Okay, another important thing that you should remember is if you take velocity time graph, okay, velocity
Okay.
and time graph. If you calculate area under the graph, you will get distance. Okay,
Mm-hmm. Yeah.
area under velocity time will give what? Distance. Okay, so if in this graph you have to find out what is the distance covered between 10 and 20 seconds. Okay, so then what is the distance? You calculate this one. This is actually this is this rectangle. This rectangle, what is the area? The length is 10, right? Height is what? 18.
Height is
18, this part, right? 18 into 10, 180 plus this part, this
height
right
is
angle triangle.
14. How?
This much is 18, no? This part.
Not 20. Oh, it's a once. Yeah. Okay. Okay.
One
Understand.
slot
Understand.
is left open, no?
Yeah.
So it is not 20. Okay, that's what he is doing. He would have done. I think he did not do. Okay. So what you have to do? You have to calculate area of this one and area of this right angle triangle. Basically, half into base into height plus length into breadth. Okay. What is base? Base is 10. Half into 10 into whatever. This is some 15 or 18 or whatever. Okay. Let's say if it is 15 plus this 10 into this 10 into this 18. Okay, ma? This is the
Right.
total distance. Agreed.
Agreed.
Okay. So now what is the important thing here? Distance in velocity time graph is area under the graph. Okay.
Okay.
In velocity time graph, distance is area. Okay. In distance time graph, velocity is this by this slope. But you don't have slope, I think. Okay. You have just have the area concept. Okay. Velocity time relation. Okay, you tell me what is this graph about? Is it constant velocity? Velocity is increasing, decreasing. What exactly is this?
Velocity is increasing.
Increasing. Velocity is increasing, right? And
Constant.
this is a straight line. That
Uniform.
means it is
Uniform acceleration.
constant acceleration or uniform acceleration. Okay.
Hmm.
Okay. Now, is there any other graph that they have given? No, they did not give any other graphs. Okay. Okay. Now, okay. Another important thing. If the velocity time graph is like this, what does that mean?
Um.
Velocity is continuously decreasing, right?
Yeah, it's retarding. Yeah.
Uniform retardation. Okay. Constant deceleration. Okay, ma?
Okay.
Okay. Distance time graph is like this. What does that mean? Velocity is like this.
Uniform motion.
Distance time will mean velocity time like this. What is the
Uniform
acceleration
motion.
here?
Uniform motion. No.
Uniform motion. What is the acceleration?
Acceleration is
Acceleration is
mat
zero, no? Acceleration is
zero.
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 Okay,
Right.
velocity is not increasing. So if distance time is given like this, what is the acceleration? Acceleration is zero. Okay, if distance time is given like this, what is acceleration? Velocity time is something like this. So acceleration is greater than zero. Understood?
Understood.
Understood. So now, if distance time is given like this, Okay, what is velocity time? Velocity time is like this because it is slowing down, right? What does that mean? Acceleration is less than zero. Acceleration is negative. Okay, it's a retardation. Understood, no?
Understood, sir.
Okay, so in all the cases, velocity time, this part, this area is equal to what? Distance.
Okay.
In all the cases, everywhere, velocity time, whatever, this area. Okay, this area is equal to distance. Okay, ma?
Yeah.
This area, everywhere, the area is equal to distance. Okay, so what you need to know, distance time, there are three kinds of graphs: constant velocity, acceleration, deceleration. Okay, for each part of this, for each one of this, velocity time will be like this or like this or like that. Okay, constant velocity means this one is flat and a is 0. Accelerating graph means this one is increasing, a greater than 0. Decelerating graph means this one is decreasing, a less than 0. Just draw these three figures. Okay, just draw these three figures in a notebook so that you don't forget.
Can you just highlight them? Which ones I should write? Because
Okay, so distance time. Okay, distance time is like this. Okay,
okay,
this and a equals to 0. You just write it. Okay, distance time is constantly increasing. Okay, that means velocity is constant, and that means acceleration is 0. Okay, these three will make one part. Okay, distance time, velocity time, and that means a equals to 0.
constant
Understood?
velocity.
Constant velocity, a equals to 0 is here. This is a equals to 0. This, this, and a equals to this. Okay,
Yeah.
that is first part of the story. Okay,
A
now
equals 0 and
that's it. These three things go together: distance time, this graph; velocity time, this graph; and a equals to 0. These three will make one piece. Okay,
okay,
this is one piece. Okay, what
okay,
is the second piece? Second piece is this one. Distance time is a graph like this. Okay, velocity time is a graph like this, and that means acceleration greater than 0.
okay.
Understood, no?
Understood.
Okay, now the third piece is a graph like this. Distance time is slowing down. This is decelerating graph. Distance is slowing down. That means velocity is decreasing. That means acceleration is less than 0. That is this graph. In all the three cases, area in velocity time is distance. In all the three cases. Okay?
Okay, sir.
Okay? You'll remember this, no?
Yeah.
Okay. So, this is about graphs. So, graphs we have finished. Okay. Now we'll go to this chapter 2. You will tell me what is this chapter 2 about. Okay? Uh, let's start. Can you see my screen, ma?
Oh, I was on mute and I was speaking. I'm saying I have seen this chapter, but I don't know much about it.
We did it? No.
I forgot.
Oh, that's okay. Then let's read it again. Let's start from the beginning. Okay. Just read it.
How do we judge whether milk, ghee, butter, salt, spices, mineral water, or juice that we buy from market are pure? Have you ever
Hmm.
noticed the words pure written on the backs of these consumables? For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is so please scroll.
Hmm.
Milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of the substance are the same in their chemical nature. A pure substance consists of a single type of particle. In
Hmm.
other words, a substance is a pure single form of matter.
Hmm. Okay,
A
what is
pure
it saying
substance
basically?
consists of a pure substance consists of a single type of particle. In pure other words, substance is a pure single form of matter.
Hmm. So what are mixtures?
Mixtures are constituted by more than one kind of pure form of matter. We
Hmm.
know that dissolved sodium chloride can be separated from water by the process of physical process of
Hmm. Evaporation.
evaporation. However, sodium chloride is itself a pure substance and cannot be separated by physical process into its chemical components. Similarly,
Okay,
there is a substance.
understood, no? So
Yeah,
what is it saying? The way we define pure in English is different from what chemistry defines. Okay,
yeah.
in English,
In chemistry, a pure substance consists of a single type of
uh,
substance only.
right. Pure substance cannot be separated by physical process into chemical constituents. Okay, this is the definition. Okay, see here, and cannot be sub this one. Okay, pure substance you cannot separate. Okay, what is a mixture? More than one kind of pure substance. Okay, ma?
Yeah,
Okay.
yeah.
Now, what is the solution?
A solution is a homogeneous mixture of two or more substances. You
Hmm.
come across various types of solutions in your daily life.
Hmm.
Lemonade, soda, water, etc. are all examples of solutions.
Hmm.
Usually, we think of a solution as a liquid that contains either a solid, liquid, or gas dissolved in it.
Hmm.
But we can also have solid solutions and gaseous solutions.
Hmm.
In the solution, there is homogeneity at the particle level. For
Hmm.
example, lemonade tastes the same throughout. This
Hmm.
shows that particles of sugar or salt are evenly distributed in the solution.
Okay. So basically, what is the solution? Solution is homogeneous mixture of two or more substances, right?
Yeah,
Agreed, ma. So it is homogeneous. So all should be equally distributed. Homogeneous means, right?
okay, yeah.
Okay. What is an alloy?
An alloy is a mixture of two or more metals or a metal and non-metal and
Hmm.
cannot be separated into their components by physical methods.
Hmm.
But still,
Very
an
good.
alloy is considered a mixture because
Hmm.
it shows the properties of constituents and can have variable composition. For
Very good.
example, brass is a mixture of approximately 30% zinc and 70% copper.
Okay. You just remember this number also. Okay. Uh, Now, solution has got two important things. What are those called? What is solute? What is solvent? Which is the bigger one? I can't hear you, ma.
Sir, I don't know
Hello.
what happened. I got disconnected.
Okay. In solution, what is solute? What is solvent?
Solute is the component of the solution which gets dissolved, and solvent is the larger part which dissolves the solute.
Right. Solute is the smaller one. Okay. Salt in water. What is salt?
Salt is a substance.
Solute or solvent?
Oh, like that. Solute.
Salt is solute. What is solvent?
Solvent is the water, like in
Okay,
salt
okay.
water
Okay,
solution.
can you give some more examples?
A sugar water.
Very good.
Also like something like Coca Cola or something because Coca Cola has gas.
Okay. So, that is fine. Okay. Or otherwise, you can give this basic example, air.
Oh, right, air also. Hmm.
Okay. Give these examples. Sugar solution.
Solution of
Okay.
can you
And
say that
and
again?
and your soft drink solute. What is soft drink? What is solute? What is solvent?
Soft drink is the solvent and solute is the like carbon dioxide.
Right. So water is the solvent and carbon dioxide is the solute. Okay.
Yeah.
Okay. Now, What are the properties of solution? This is important. Okay,
A
you should
solution is
remember
a
this.
homogeneous mixture. The
Hmm.
particles of a solution are smaller than 1 nanometer in
Hmm.
diameter, so they
Hmm.
cannot be seen by naked eyes.
Hmm.
Because of very small particle size, they do not scatter a beam of light passing through the solution. So the
Hmm.
path of light is not visible in a solution.
Hmm.
The solute particles cannot be separated from the mixture by the process of filtration. The
Hmm.
solute particles don't settle when left undisturbed, that is, the solution is stable.
Okay. Now tell me what exactly are the properties
Sir,
without
can I go
looking
to
at
the washroom once?
without looking. Just look at this for a second, and then I will remove the screen. You should be able to tell these 4 points. Okay.
Particles of a solution are small. A solution is a homogeneous mixture. Particles are 1 nanometer.
Hmm.
Uh, do not scatter a beam of light.
Hmm.
Cannot be separated from the mixture by the process of filtration.
Okay. Now tell me what are the 4 points?
Solution is a homogeneous mixture.
Very good. Excellent.
The
Hmm.
particles are very small,
Hmm.
of 1 nanometer size, and cannot be seen by naked eyes.
Very
Uh,
good.
it
Excellent.
cannot scatter a beam of light.
Very good.
Also, cannot be separated by the process of filtration.
Very good. Very good. Excellent. So these are the properties of solution.
So, can
Okay.
I go
So
to the washroom once?
okay, ma'am.
Yes, sir. I'm back.
You are back, ma'am.
Yes, sir. I'm back.
Okay. Very good. So properties of solution, right? So now what is okay? Continue. What is concentration of a solution?
We understand that in a solution, the relative. So, just a second. Yes, sir.
Hmm. The proportion
Solution,
of the solute.
the proportion of the solute and solvent can be varied depending upon the amount of solute present in a solution. It can be
Hmm.
called a dilute, concentrated, or saturated solution.
Ah,
When is the amount
okay. Now
is
is the amount of salt and sugar?
is the amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature the same. At any particular temperature, a solution that is dissolved as much as it is capable of dissolving is said to be a saturated solution. In
So
other
wait.
words,
What is a saturated solution?
at any particular solution,
Hmm.
when the solution
Hmm.
at any particular temperature, when the solution has dissolved
Hmm.
as much solute as it's capable of dissolving, it's said to be saturated.
Okay. So in a saturated solution, if you put more of the solute, what will happen?
It will not dissolve. Be
It
able
will
to.
it will be just lying down. Okay.
Yeah.
For example, if a dog is eating food, it can eat up to a level only. If you put more food, what will happen? It will be
Might
lying down.
vomit.
It will be lying down. It will be wasted. Similarly, here also, water can dissolve certain amount of salt only. If you put more salt, what will happen? The salt will be lying down. It will not be dissolved. Okay. So that how much amount you put is the question here. Okay. What is saturated? Saturated means it cannot take any more. Okay.
Okay. Yeah.
Okay. Now, this is always at a particular temperature. If you change the temperature, probably it can eat. It can take more. Okay, ma? Okay. So
Yes,
now,
sir.
what is solubility?
Solubility refers to the amount of solvent that can solute present in the saturated solution
Okay.
at a given temperature.
It is in saturated solution, not in any random solution. Okay.
Right.
Okay. In saturated solution. If it is lesser, it is unsaturated. Okay.
Yeah.
Very good. Now there is okay. Continue.
We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. The
Hmm.
concentration of a solution is the amount of solute present in a given amount of solution.
Hmm. Ah.
It can be inferred by three methods.
Hmm.
Number one, mass by mass percentage of a solution,
Hmm.
that is mass of solute upon mass of solution upon 100. Then
Into
mass
100
by
times 100, not upon 100. This 100 is in the
into
numerator.
100.
Okay.
Yeah. Okay.
So then what else? Mass by volume. And
Mass of solute by volume of solution equal into 100.
right.
Then volume by volume percentage of a solution.
Very good.
Volume of solute upon volume of solution up
Okay.
into
Very
100.
very good. So now you tell me, solve this and tell me 40
Uh,
grams, 120, 320 grams. What is mass percentage?
100 by 8,
100 by 8, right?
which equals
No, no,
112
wait,
by 5? No.
wait. So you have to be careful here. So 40 by 40 plus 320. Okay. Understood. Not just 40 by
Oh,
320.
right, I forgot.
Okay. So you'll make this
So
mistake.
100 by 9.
So 100 by 9 exactly, which is 11.1%. Okay. Very good. Uh, Now what is the suspension?
Suspension is a heterogeneous mixture in which the solute particles don't dissolve but remain suspended through the medium, bulk of the medium. Particles of a suspension are visible to the naked eye.
Very good. Understood, no?
Right,
Okay.
yeah.
Okay. Tell me what are the properties of solution once again? 4 points.
Solution is a heterogeneous mixture.
No. Solution, not suspension.
No, I'm saying solution. Oh, sorry, I said heterogeneous. Sorry.
Right. Solution
Solution
is
is a homogeneous mixture. It's like
uh,
really small in size.
very
Its
good.
diameter is 1 nanometer.
Right. That is
No,
the
its
second point.
size is 1 nanometer.
Size is
It
1 nanometer.
it can't be visible by naked eye.
Very good.
And 1 second. Yeah, it doesn't scatter the beams of light,
Hmm.
and it cannot be filtered by the process of filtration.
By any physical process.
Okay.
Okay.
Huh.
So the solid particles come by method of filtration. Okay.
Yeah.
Okay, and they do not settle down when left undisturbed. Solution is stable. Okay, path of light is not visible. Very good. Now, what is the suspension?
What?
What is a suspension?
Suspension is a heterogeneous mixture in
Hmm.
which the solid particles don't dissolve but
Hmm.
remain suspended through the bulk of the medium,
Ah,
visible to the naked eye.
visible to the naked eye. What is meant by homogeneous?
Homogeneous mixture is
Hmm.
a mixture with like two or more substances.
Mixture of two or more substances. That is why, right? But they are uniformly distributed.
Yeah, right.
Okay, this one. They should be evenly distributed. Okay, so it is at a particle level. You cannot see with the naked eye. Okay.
Yeah.
Agreed, ma? Okay. Now, this is about suspension. Now, tell me what are the properties of suspension?
It is a heterogeneous mixture. It is visible to the naked eye. It scatters a beam of light, so Tyndall effect happens.
Very good, very good.
Uh,
See, the particles of
it can
surface
be
can beam of light
separated by
through it
some
and make its
process of
path
filtration.
visible. Okay,
Yeah.
okay. That is what is why is it unstable? because if you leave it alone, the particles will drop down. Okay.
Yeah.
Okay, they will come to the bottom, and that's why you will be able to separate with using filtration. Okay. Now, what is we talked about uh, homogeneous, we talked about solution, we talked about suspension. What is the colloidal solution?
Uh, it is a mixture of both. Are
Particles are
uniformly
uniformly
spread.
spread
The
throughout the
particles of
solution.
a colloid are
Uh,
uniformly spread throughout the solution
uh.
due to relatively smaller size of particles as compared to
Firstly, colloidal is homogeneous and heterogeneous.
homogeneous.
No, 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 no. So it's
They
actually
appear
heterogeneous.
homogeneous.
Heterogeneous. It looks like homogeneous. Okay.
Yeah,
The difference between suspension and colloid is suspension you can see the particles because they are big enough. Colloidal you cannot see the particles because they are small. Okay.
yeah,
You cannot see, but they are actually heterogeneous. Okay. Okay. But they can scatter a beam of light.
yeah.
Okay. And what you can see? You can see Tyndall effect.
Correct.
Okay, ma?
Yeah. Yes.
See here, copper sulfate. This one cannot show, but water and milk it will show.
Okay.
Scattering of the light. Okay, ma?
Yeah.
That is Tyndall effect. This is Tyndall effect. Okay.
Yeah.
Uh, Mist is what? This is also kind of colloid. Okay. Colloid dispersed in air. Okay. Okay. Now tell me what are the properties of colloid?
The properties of colloid are colloid is a heterogeneous mixture. The size of particles of colloid is too small to be individually seen by naked eyes,
Hmm.
but the colloids are big enough to scatter a beam of light passing through it,
Hmm.
and they don't settle down when left undisturbed.
Okay. Colloid is stable. Okay. Solution is also stable, but suspension is not stable.
Okay.
Okay, ma?
Yeah.
Okay. Cool. So we'll stop here. Okay. Remaining we'll see in the next class. Okay, ma?